Yeah, now let's check the control circuit connections of half wave rectifier and full wave rectifier circuit. We have this is the kit, the control circuit kit of full wave rectifier and half wave rectifier circuit, and this is the AC supply what we have supposed to give. So we have given the AC supply from a transformer. This is a step down transformer. It is powered to 230 volts. From 230 volts it will step down the AC voltage to 15 volts, and 15 volts AC is provided here. From transformer positive it's given to positive here phase, and from 0 it's given to neutral. From 0 it's given to neutral. Okay, this is the connection what we are supposed to do for AC side. And since it is a control circuits, we have many ICs inside this. Okay, we have many ICs. So to power this ICs, we need to provide DC supply as well. So what we are doing here, we are giving from plus 15 volts, it's given to, we are using RPS here. From plus 15 volts, it's given to plus 15 volts in the kit. We are giving plus 15 volts in the kit, and from common it's given to 0. From minus 15 volts it's given to minus 15 volts. Okay, this is the connections that you are supposed to do for the control circuit. Now what we need to do is we need to generate the firing pulses. As I told, we are giving AC supply here. Rectifier will convert it into pulsated DC, and zero crossing detector will detect the zero crossing, and ramp generator will generate the ramp signals in synchronism with the AC supply, and it is compared with DC. Then the output of this comparator will be the firing pulse. It is given to high frequency pulse generator, which converts continuous triggering pulse to continuous pulses. Now this is given to comparators or AND gate, which segregates the pulses between 0 to 180 degree and 180 to 360 degree. Here G1 K1, G2 K2 will be in phase. Okay, the firing pulses generated here will be within 0 to 180 degree, and the firing pulses generated at G3 K3, G4 K4 will be between 180 to 360 degree. Now let's switch on the supply and let's check the waveforms. Now I am going to switch on the DC supply, and then let's switch on the AC supply. Now let's check the waveforms. First, let me show you the waveforms across AC supply. I am connecting the CRO probe. I am connecting CRO probe to check the AC supply waveform, and I have connected the supply. Okay, this is the AC voltage. Now let's see how to do RL load connections. Now what we have cathode connection of T1 and T3. From here the connection is going to ammeter positive. From ammeter negative it's going to R. From R it's going to L. From L it's coming back to diode. Okay, this is how you can connect RL in series. Now let's switch on and let's observe the waveforms across load. Okay. Now there won't be any difference between R load and RL load in case of half control rectifier, because we have diodes in the circuit. Okay, these diodes acts as freewheeling diode. As a result, negative supply won't appear across the load, or whenever the inductor is discharging, the current will freewheel through this diodes. As a result, it won't come across supply, so you won't get any negative pulse here. The waveforms will be similar to R load. Okay, now the value of alpha is 18 degrees. The output voltage is 275 volts, and alpha is around 45 degrees, and the output voltage is 219, and alpha is 90 degree. Output voltage is 129. Alpha is 90 plus 18. Output voltage is 78.3. Okay, this is how you can note down the values of a rectifier output voltage when you have connected RL load. Okay, one thing to be remembered, whenever you are measuring voltage across load in case of half controlled rectifier or full controlled rectifier, multimeter should be kept in DC mode. Okay, now let's start with the connections of single phase half controlled rectifier. Okay, this is the experiment what I am talking about. Experiment number 6, single phase controlled full wave rectifier with R and RL load. And first part in this is control half controlled bridge rectifier circuit with R and RL load. In half controlled, as I told, we'll be having 2 thyristors and 2 diodes. First, let's look at the control circuit. First, let's look at the circuit connections. Then we'll see the waveforms across control circuit. Then we will see the output voltage waveform. Okay, now let's look at the connections of the control circuit. In control circuit, we have 2 parts. First one is AC supply. AC supply we are giving from a transformer. The transformer is connected to 230 volts main and it is stepping down the voltage to 0 to 15 volts. This 0 to 15 volts is connected across AC supply in the control circuit. Next, we are connecting 15 plus 15, 0 and minus 15 through RPS. Okay, this DC supply is to operate the ICs. This AC supply is used to generate the firing pulses in synchronism with the supply voltage. Now, let's look at the main circuit connections. Okay, first, anode. First, these two are connected. Cathode and cathode of thyristor. Then anode and anode of thyristor are connected. Then from anode of thyristor to cathode of diode 1. Then from anode of thyristor 3. In manual it's shown as T2, but here I am using thyristor T3. Okay, from T3 anode to D2 cathode, 1 connection is provided. Now, okay, the AC supply, 230 volts AC supply is connected between 2 anodes. Okay, the junction where you have connected cathode and anode of diode and thyristor, first leg positive or phase is going and neutral is going to the connection where T3 anode and D2 cathode are connected. Now, from T1, T3 cathode connection, the wire is going to ammeter positive. From ammeter negative, it's going to load. From load, it's going back to diode, diode anode junction. Okay, in manual, it's shown in the circuit diagram, 1 ohm resistance is shown. You can neglect it. First, we are conducting the experiment with R load. Then we will be performing it for RL load. Now, let's switch on the supply and let's look at the waveforms across different points. Now I'm switching on the power supply. Okay, now first let's see the voltage 15 volts which is connected across the control circuit. Okay, this is the waveform of voltage across the AC supply what we have given to the control circuit, and we can check it's in AC mode, ground we can adjust, then we will get AC voltage. It's 1 division, 2 division. 2.6 into 0.1 is 0.26 into 100 is 26. So 26 volts we are getting peak value. So 15 volts is the RMS, 26 volts is the peak value. Now this AC voltage is getting rectified through a diode rectifier. As a result, we are getting rectified voltage. Since it is rectified voltage, I am keeping it in DC mode. So this is the voltage across rectifier. Okay, now it is also 1, 2, 2.4, 2.4 into 0.1 is 0.24, into 100 is 24 volts. Okay, the peak value of this rectified output is 24 volts. Now, ZCD is zero crossing detector. You can observe here, this is the zero crossing point of a rectified output voltage. At that same point, we are getting the firing pulse. Now, in synchronism with ZCD, the ramp signal is generating. Okay, the ramp is generating at this point. Now, this E is the control reference signal. Okay, as I vary this spot, this E will be varied. You can observe the reference is moving up and down. The straight line is the DC reference. It's moving up and down. This is the reference voltage. Now, this is the firing pulse what we have obtained after comparing ramp signal and reference signal. I am varying alpha here. Okay, this is the reference point. With reference to this, the alpha is 90 degrees right now. Because as I told in the previous videos, one small division is 18 degrees. 18 into 5 gives 90. So this is the firing pulse what we have. Okay, now this generated firing pulses will be available at G1, K1, G2, K2, G3, K3, G4, K4. G1, K1, G2, K2 will be in phase. G3, K3, G4, K4 will be out of phase. So one pulse between the duration 0 to 180 degree is given to T1. One pulse which is at 180 to 360 degree duration is given to T3. Now let's look at the voltage waveform across the load. Now let's look at the voltage waveform across the load. Okay. Now, exactly the alpha is 90 degree. Okay, I can vary the alpha here. This is R load, so I have connected the CRO across resistive load. Now what I am going to do, I am going to vary alpha. Now alpha is equal to 18 degree. At that point, you can observe the waveform and you need to measure the voltage across load using multimeter. Okay, measure the voltage across load using multimeter. Now let me show you the variation in alpha. Okay, you can vary the alpha further. Okay, now the alpha is covering two divisions, that is 36 degrees. Alpha is equal to 36 degrees now, and this is the waveform for alpha equal to 90 degree. Okay, you have to draw this waveform alpha equal to 90 degree. Now when you observe the voltage across the load, I'm going to connect multimeter across load and load one terminal is going to ammeter, so I'm putting it here, and load other terminal is going here. Okay, and the mode should be in DC mode because rectifier output will be DC. Rectifier converts AC to DC. Now for alpha equal to 90 degree, the output voltage is 150.2. Let's see the values from 0 degree. When alpha is equal to 0, the output voltage is 300, around 300. Now I am increasing the value of alpha. When alpha equal to 18 degrees, the output voltage is 289. Okay, and when you increase alpha further, for alpha equal to 36 degrees, the output voltage is 275. When alpha equal to 36 plus 18 degrees, the output voltage is 233. Now when alpha is equal to 90 degrees, the output voltage is 138. And for alpha equal to 90 plus 18, that is 108 degrees, 79.5. Okay, like that, the full range of alpha values, you have to vary the alpha over the obtained range, and you need to note down the voltage by keeping multimeter in DC mode across the load, and you need to observe the waveforms across the load. Okay, this is what half control rectifier with R load. Let's look at the connections of fully controlled rectifier. There is no much difference in the connections of half control rectifier and fully controlled rectifier. In case of fully controlled rectifier, D1 and D2 were connected in the lower side. Now instead of 2 diodes, we are going with 4 thyristors. In half controlled rectifier, we had 2 thyristors and 2 diodes. In fully controlled rectifier, we will be having all 4 thyristors. Okay, the connections remain same. The only differences in place of D1, D2, we will be using T1, T2. So from T1 anode, the connection is going to cathode of T4. From T3 anode, the connection is going to T2 of cathode of T2. And from G2, K2, we will be giving to G2, K2. G4, K4 is going to G4, K4. Now let's switch on and let's look at the waveform. Now, as you vary alpha, so now the minimum alpha is 36 degrees. I have kept the alpha at 36 degrees. You can read it clearly. one small division is equal to 18 degrees. So the shot is covering two small divisions. That is, with reference to this, you are turning on the thyristors at this point. So your alpha is 36 degrees. When alpha is 36 degrees, the output voltage is 191 volts. Now as I increase alpha, now I kept alpha at 45 degrees, the output voltage is 184. Alpha I have kept it at 90 degree, the output voltage is 111. And I increased alpha to 108 degrees, the output voltage is 75. And alpha is increased to 36 plus 90. Now the output voltage is 42. Okay, like this you can vary the value of alpha and you can note down the voltage across resistive load in case of fully controlled rectifier. And I want you to draw one value waveform for any value of alpha. The waveforms and voltage across inductive load, that is RL load, in case of fully controlled rectifier. Okay, now I am varying alpha at when alpha equal to 36 degrees, the output voltage is 311. And you can observe here during this period alpha to pi inductor is charging, and during the period pi to beta the alpha inductor is discharging. This is the reason why the supply voltage negative cycle is appearing across the output. And we don't have any freewheeling diode here. We didn't use freewheeling diode here. This is the reason why the supply voltage is appearing across the load. Now, as I vary alpha further, for alpha equal to 45 degrees, the output voltage is 208. And for alpha equal to, okay, till maximum 90 you can take in this. For alpha equal to, like this, by varying alpha you need to take down the readings. When alpha equal to 18 plus 18 plus 18, 36 plus 18, the output voltage is 166.9. Okay, this is how we can perform the experiment of fully controlled rectifier.